Section 5.3 is about adding and subtracting rational expressions. It seems kind of weird because in the previous section we did, pardon me, we did multiplying and dividing rational expressions, and usually we do adding and subtracting before we do multiplying and dividing. There's a reason for it. Let's take a look at the warm up here a second. So we have two problems. They're just straight up addition problems with fractions. We've got 2/3 plus 1/2. Now remember, in order to add fractions together, we got to have common denominators. So right now we have a denominator of 3 and 2. The only way we can get them to have common denominators is if we multiply this first denominator by 2 and the second denominator by 3. But to do that, we got to make sure we multiply both the numerator and denominator by the same value. So we're going to do 2 times 2 over 2 times 3. That's going to give us 4/6. This is just producing an equivalent fraction. So 2/3, 4/6, same thing. For 1/2, we're going to multiply the numerator and denominator by 3. So we'll end up with plus 3/6. Again, equivalent. It's an equivalent fraction to 1/2. So now we can add these together. 4/6 plus 3/6. Now when we add fractions, add the numerators together. If they have a common denominator, we get 7/6. And that's all. If you want, you can express it as 1 and 1/6. I would prefer probably is an improper fraction like 7/6. For the second one, 2/9 plus 1/4. Same type of deal. I'm going to multiply this first fraction by 4/4. That would end up giving us 8/36. Again, that's an equivalent fraction to 2/9. If I multiply the second one by 9/9, we end up with 9/36. Again, an equivalent fraction of 1/4. When we add these together, we end up with 17/36. That's not a reducible fraction, so we're going to leave that one as is. Cool. So just a quick refresher on adding and subtracting fractions. Well, in this case, just adding. For our goals for the day, we're going to add and subtract rational expressions. What we mean by that? Well, just like subtracting fractions require common denominators, same thing are going to happen for rational expressions. It's just going to be a little bit more complicated. So, for example, we're asked to add and subtract these two fractions, these two rational expressions, and identify any x values for the expression that are undefined. This is not too bad because you'll notice they already have the same denominator of x plus 4. So what we can do is just add your numerators as is. So to add your numerators as is, what we're going to do, and I'm going to actually put these in parentheses just for safety's sake. There's a reason for it. We might run into that in a little bit. We're going to add x minus 3 plus x plus 2. So let's add the combined like terms. We got x plus x. That gives us 2x. We have negative 3 plus negative 2. That gives us negative 5. And we already have a common denominator of x plus 4. And that's all. That one was not too painful. Sorry, waiting for AirServe to catch up. There we go. That one wasn't too painful. They already had a common denominator, so we didn't need to get anything or do anything crazy with it. The second part, it asks us where it's undefined. It's undefined whatever makes your denominator equal to 0. And remember, thinking back to the previous section, it's whatever makes any of your denominators equal to 0, including the original denominators. In this case, the denominators are all the same. So it's undefined at x equals negative 4. All right, let's get a little more complicated. That one wasn't so bad because the denominators were already nice. This next one is more difficult. We are asked to add these two expressions together. We've got x minus 3 over x squared plus 3x minus 4 plus 2x over x plus 4. They do not have a common denominator. They both conveniently have x's, and they also both coincidentally have 4's in them. Keeping in mind one strategy to work with in Algebra 2, if you're ever stuck and you're not so sure what to do, especially dealing with something that has like a quadratic in it, try factoring. So in that first fraction, I'm going to leave the x minus 3 alone. In the denominator, x squared plus 3x minus 4 can be factored out into x plus 4 times x minus 1. Again, keeping in mind because 4 times negative 1 is going to give us that negative 4. And 4 plus negative 1 is going to give us that positive 3. The second fraction is still 2x over x plus 4. Okay, that didn't really get us that much closer to what we need because we still have two unique denominators. Well, to get the second fraction to have the same denominator, you'll notice they both conveniently have an x plus 4 in it. So what we're going to do is we got to now multiply the second fraction by x minus 1 on top and on bottom. Now again, I started using parentheses in the last problem. I'm going to start using parentheses more here as well. Because we got to multiply that whole numerator by x minus 1 and that whole denominator by x minus 1. So I'm going to leave that first fraction alone. Let me zoom out a little bit. We have x minus 3 over that First denominator, we factor out into x plus 4 times x minus 1, and we're just going to leave that there for now. Sorry, I didn't mean to put that stray mark there. So the second fraction, we're going to take the 2x and distribute it to the x, and that gives us, oops, sorry, this is supposed to be a plus here. So the 2x gets distributed to the x, and that gives us 2x squared. The 2x also gets distributed to negative 1, so that gives us negative 2x. All over our now common denominator of x plus 4 times x minus 1. Again, I emphasize they are now a common denominator, so we don't need to change anything else. So now we've got a common denominator. We can add our numerators together. So going through it in order from highest exponent to lowest exponent. This first fraction doesn't have any x squareds, but this one does. So it's like 0x squared plus 2x squared. That gives us a grand total of 2x squared. We have 1x and then plus negative 2x. So that's going to give us negative 1x, or negative x. And we also have that negative 3. There's nothing in the other group, so it's just going to be negative 3 plus 0, or negative 3. All that over still x plus 4 over x minus 1. Now you might be wondering why I haven't why I haven't remultiplied that. Well, we already know what that is. X plus 4 times x minus 1. That just brings us back to the original. I'm going to leave it there because there are times where we might need to take this a step further. What I'm going to have us do here is I'm going to have us practice this next step, and I'm also going to acknowledge we don't technically need to do it on this one because we're going to take a step and it's not going to do us any good. But that numerator is technically factorable. I'm going to leave that denominator alone, x plus 4 times x minus 1. The numerator, we can break it down into two separate groups, but it's not going to be x plus blank, x plus blank. One of them's got to be 2x, and the other one's got to be x, because when we multiply these two together, it's going to have to give us that 2x squared. Now these two numbers are going to have to multiply to negative 3, so it's going to be a positive 1 and a negative 3, or negative 1 and positive 3, maybe in a different order. But they're also, when we do this 2x times whatever this is, plus whatever this is times x, it's going to have to give us a grand total of negative x. For time's sake, I'm just going to kind of jump to it. It's going to be a negative 3 and a plus 1. Just demonstrating again why that works. So we have 2x times x gives us 2x squared. 2x times 1 gives us 2x, but then we also have negative 3 times x, which would be negative 3x. So we'd have 2x plus negative 3x, that's going to give us that negative x. We also have negative 3 times positive 1, that gives us that negative 3. Now, I had us do this even though, again, this one technically doesn't help us. What we want to do is we want to factor out the numerator and denominator as much as possible once we get it as one single fraction, because there will be instances in which we can simplify it further. We could like maybe slash some things like we did last section. But this one, that's as far as we can go. Now it does ask us where it's undefined. Again, it's undefined wherever any of your denominators are equal to 0. So it's undefined at, in this case, our denominators, well, they have x plus 4 and x minus 1 in them. So it's going to be at x equals negative 4 and at x equals positive 1, because both of those would make your denominator equal to 0. One more example. This one is going to be a little bit different, but the same general concept. This one we're asked to subtract these two. So to subtract these two fractions, again, common denominators, they don't have a common, or they're not common yet, but we'll work on that. So again, if you're not so sure what to do, start by trying to factor. That first numerator, we're going to leave it as 2x squared plus 64. The denominator, x squared minus 64. X squared is a square term. It's got it in the name. 64 is also a square number. It is the same as 8 squared. So this can be factored out like the difference of 2 squareds, where we have x plus 8 times x minus 8. Again, oops, sorry, not 1, minus 8. Again, you can put that in whatever order you want. X minus 8 times x plus 8, as long as you've got one of each. The second fraction, still x minus 4 over x plus 8. Now again, you'll notice they very conveniently have an x plus 8 in them. So to get a common denominator, we're going to have to take the second fraction, and again, parentheses are our pals. We're going to multiply it by x minus 8. Why do I keep writing 1? X minus 8 in the numerator and wow, can't write right now. X minus 8 in the numerator and denominator. So when we do that, I'm going to leave that first fraction alone. Just going to rewrite it. So we have 2x squared plus 64. And now for the numerator on that second fraction, sorry, let me finish off this first fraction. That numerator on the second fraction, let's actually multiply it out. X times x. Oops, sorry, that's a minus. So x times x gives us x squared. X times 8, or sorry, negative 8 gives us negative 8x. But then we also have negative 4 times x. So that's going to give us negative 4x plus negative 8x, gives us a grand total of negative 12x. And then finally we have negative 4 times negative 8, which gives us positive 32. That's still all over our new denominator, our new conveniently common denominator of x plus 8 times x minus 8. So again, we've got a common denominator now. We can start adding things together. So looking at these, we've got 2x squared. Let me change my colors a second. We got 2x squared, and now we're subtracting everything in that second fraction. So if it helps you to put it in parentheses, so it's like we subtract x squared. So 2x squared minus x squared is just x squared. Then we have no x to the first, so it's like 0x in this one, minus negative 12x. That's going to give us plus 12x. Then we have a 64 minus 32. So that's going to give us plus 32. All that over x plus 8 times x minus 8. Okay, now we've got them as one single fraction. But folks, as I said, sometimes it's helpful to factor. This one definitely will be. That numerator, x squared plus 12x plus 32, that's factorable into x plus a number, x plus a number. We need two numbers that multiply to 32 and add to 12. Well, that's x plus 8 and x plus 4. All that still over x plus 8 and x plus 4. No, sorry, x minus 8. Goodness gracious, I started looking at the numerator. Now with this, and I conveniently had them lined up, but it doesn't matter if they line up. If they both have a factor of x plus 8 in them, you can cancel those out. You can go ahead and slash them. So we end up with just x plus 4 in our final numerator over x minus 8 in our final denominator. So that is the fraction as simplified as it can be. Now again, we got to say where it's undefined. It is undefined at x equals 8. Because if we plug in x equals 8 here, you get a denominator of 0. We can't have that. But wait, there's more. We also got to go back to our unsimplified, our uncanceled out denominator. We also have to say, because it didn't work here, it can't work in the final. So x also can't be equal to negative 8. So it can't be equal, or it's undefined at x equals 8 and at x equals negative 8.